Yeah. So this is the numerical state of stress for an element of unit thickness is shown in figure. Find the normal stress and shear stress that must act on the inclined dotted line, that is this line, to keep the element in equilibrium, and show the resultant on inclined plane with proper orientation, right? So this is the question. Now either you have to remember both the equations and solve it, or now for the equations which I have derived, I have to convert this angle into angle with respect to major normal stress, right? So I'm just taking it here. Now let us say this is my y axis and this is your x axis, right? And with respect to y axis, the plane that is given is like this. This is the x axis. So the plane that is given is like this, and this angle is given as what? 22.12 degree. So this angle is 22.5 degree. Now the equations what I have derived, in that I have taken the angle with respect to the major normal stress, that is x-axis, right? So we have taken the sections like this, and this angle or this angle I have taken as theta. Now what I have to do is, with respect to x-axis, what is the angle of this? So this is 90 degree. So 90 plus 22.5 is my theta. That is the only change you have to do. So let me go back to this solution. Given sigma x is equal to, this is with major normal stress 3 MPa, and sigma y is equal to 1 megapascal, right? Both are tensile, so they both will be positive. Now you see this, this is tau shear stress. This is upwards and this is downward, so it is making this element rotate in counterclockwise direction, reverse, right? So tau xy is equal to minus 2 megapascal, because this is making counterclockwise rotation, so it is minus 2 megapascal, and angle of inclination theta is equal to 90 plus 22.5, which is equal to 112.5 degree, right? Now with theta equal to 112.5 degree, we have to solve the numerical. Now in my equation, I have 2 theta everywhere, right? So I think I don't have the equation for normal stress, right? Because here he has asked to calculate the normal stress. Let me just find that equation for you. This is the equation for normal stress. Right? So I'll just keep this equation here. Now let us try to solve this. What is asked is find the normal stress and shear stress that must act on the inclined dotted plane to keep the element in equilibrium and show the result on inclined plane with proper orientation. Okay. Now let us find the normal stress. The normal stress on the inclined plane is given by sigma n is equal to sigma x plus sigma y by 2 minus sigma x minus sigma y by 2 cos 2 theta minus tau xy sin 2 theta, right? Now you have to substitute the values in this. So here I will do one more thing. 2 theta is equal to 112.5 into 2, 225 degree, right? So we will be using this in our calculation. Or now I have to substitute the values, so I'm just taking the same equation again. Now go on putting the values. Sigma x is 3, sigma y is 1, sigma x is 3, here it is minus 1, cos 2 theta, 2 theta is 225, tau xy is minus 2 here, right? So it will become plus into sine 2 theta, 2 theta is 225. Now let us calculate this, right? So 3 plus 1 is 4, 4 by 2 is 2 minus 3 minus 2 is 2, 2 by 2 will be 1, so I need not do that, cos 225. So 225 cos minus of minus, it will become plus 2 plus 2 into 225 sine. Enter. So the normal stress is 1.293. 1.293 MPa. Please cross check once again with your calcs, because this online calculator, I don't know, sometimes it might go wrong. I mean, the way I put the values, it may go wrong, right? So this is the normal stress. Let us get the equation for the shear stress. So the shear stress tau, this is the final expression. Tau is equal to sigma x minus sigma y by 2 sin 2 theta minus tau xy cos 2 theta, right? So I'll just copy this expression. The shear stress on the inclined plane is given by this. Tau is equal to sigma x minus sigma y or now let us substitute the value. So sigma x minus sigma y is 3 minus 1 sine 2 theta. 2 theta is 225. Tau xy is minus 2 and cos 2 theta is again 225. So this is equal to this will become 1. So it is sine 225 minus of minus, it will become plus sine 225 plus 2 times cos 225. So 225 sine plus 2 into 225 cos. So it is minus, okay, sorry, minus 2.12 minus 2.12 megapascal. Now don't get confused why the stress is negative. Stress is negative. If the normal stress is negative, it means it is compressive in nature. If the shear stress is negative, it means it is in counterclockwise direction. Since my shear stress applied on the element is in counterclockwise, the shear stress on the inclined element is also in counterclockwise direction, right? Now we have to show this on the inclined plane. So how to show? Let me go to this pane. So this is the plane which we have considered, right? So if you want, you can show this as dotted line, like this, right? Now the normal stress is perpendicular to this inclined plane. So draw a line approximately like this, perpendicular, right? And show the arrow like this, right? So this is normal stress. Normal stress equal to how much was the value? 1.239293, sorry, MPa, right? Now the shear stress is negative, right? Minus 212. So it should be counterclockwise direction. So it will be in this direction. So show the shear stress like this. Shear stress is also tangential stress. So you can show like this. Let me just zoom it over there. And I will show the arrow like this. Yes. And this value is how much? 212, 2.12 megapascal. This is stress equal to 2.12 megapascal, right? So this is the orientation. If you want, you can show this as the normal or perpendicular direction like this. We just put this diagram back there. Because here specifically asked in the question, show the result on inclined plane with proper orientation. So you have to draw this and show the results. The results are shown on the grid, right? So this is the solution. This is for 7 marks.